Hello friends, the topic for today is 8051 stack operation and stack pointer. A computer or a microcomputer program often needs to perform a particular subtask using the familiar subroutine structure. Now, in order to organize the control and information linkage between main program and the subroutine, a data structure called stack is used. In today's video, we'll discuss the stack, its operation, and the use of stack pointer for the stack operation. Let us start. Welcome to our channel Engineering and Technology for You. If you are not subscribed to our channel, kindly subscribe and press the bell icon so that you get notifications for future videos. The topic for today is 8051 stack operation and stack pointer. Let us start with the introduction. Now, stack is a collection of registers organized in such a manner that last data item written is the first available to be read. So here the structure of stack is such that we can read the data which is written at the last. So there is only one end from where we can read. So elements can be added or removed at one end of the list only. That's why the stack is a last in first out or LIFO memory buffer or LIFO buffer. So here for stack the restriction is that only one end is available for writing or reading the data. So stack allows all read and write operations to be carried out through one end, and hence the information that goes in last will come out first. And the single register for writing or reading at a particular time is the top of the stack. So here we have the top of the stack that is available for reading or writing. So anything we want to write to the stack, it will be written onto the top of the stack, and anything we want to read from the stack, it will be read from the top of the stack. So that is only the single register available for reading or writing. So now when we write the information to the top of the stack, the operation is called push, and when we read from the top of the stack, the operation is called pop. So we can write or read from the top of the stack. Let us understand the operation. Now here you can see this is the stack. It consists of number of memory locations, and there each of this memory location acts as a register, and the only register which is accessible to the user is the top of the stack or TOS. So when we are writing to the stack, we'll have to write from this register only or top of the stack. So when we write, we call it as the push operation. So pushing will be done this way. Now once we push one element, it will be here on the top of the stack. Now if you push another element, so this element will be shifted here, and the new element will be here on the top of the stack. So in this way, the pushing operation will push the elements to the bottom of the stack. Then when we read from the stack, now we can read only from the top of the stack. This is the only register which is available for reading. So that's why when we pop, this will come out. Now it will come out of the stack and it will be stored either in a register or a special function register or memory. And when this is coming out, the other elements, they are pushed up. So the next element which will be uh, available, it will be now at the top of the stack. So in this way, the stack will operate by pushing the elements in this direction, and when we read the elements, that will be in this direction. And every time, now this is the top of the stack, so that is pointed by the stack pointer, and the pointer will be changing as per the operation. Either it will be incremented or decremented depending on the push or pop operation. Then let us see the 8051 stack implementation. Now in 8051, the stack is implemented using software. That means we are not using hardware for the stack implementation. So here a software stack is a last in first out data structure implemented by using number of RAM locations. RAM locations means the read write memory locations. So here we'll make use of a part of the RAM for the stack, and the stack size will be depending on the size of the RAM, but here the response will be slow compared to the hardware stack. Now the address of the stack is contained in a register called the stack pointer. So in 8051, stack pointer is 8-bit register, and 8051 it has 128 bytes of RAM. So that will be used for the stack operation. So that will be making the stack space, and it will, as we load the stack pointer, we can use that part of the memory for the stack operation. Then the stack pointer. Now stack pointer is a special function register or SFR which has the address 81. So 81 hexadecimal is the address for stack pointer. So always the data in stack pointer, it will be stored at this location 81, and the stack pointer always holds the 8-bit address of the top of the stack. So it will hold the address of the top of the stack, and the address will be 8-bit. Since we are having 128 bytes of memory in 8051 and the stack pointer is 8-bit, so the address of the memory, internal memory, is 128 bytes, it will be 8-bit. Then the programmer can reserve any portion of the RAM as the stack. So we can use any portion of the RAM as stack. So here we'll have to avoid the portion which is used for the registers, and the part that is the part which is used for the byte addressability, so that we can avoid and use the portion of RAM which is say scratch pad RAM. That part we can use for the stack. Now after reset, the stack pointer is initialized to 07. Now 07, now this is the address for register R7 of register bank 0. So it is initialized to 07. Now if you want, you can change the address by loading the stack pointer. Now the stack can be accessed using push and pop instruction, as we have already discussed. Now during the push operation, the stack pointer is automatically incremented by 1, and during pop operation the stack pointer is automatically decremented by 1. So the push operation, when we are pushing, at that time the stack pointer is incremented by 1 and then the data is written, and during the pop operation it will be decremented by 1. Then let us see the push and pop. Now the push and pop instructions are used to manipulate the stack related operations. Now in these instructions, data moves between an area of internal RAM, that is nothing but the stack, and the specified direct address. So in the instruction we specify a direct address for the push and pop operations. So that will be used, and the stack area, that will be used for the stack. Now a stack pointer contains the address in RAM where the data from source address will be pushed or where to be popped to the destination address is found. So that's why when we actually push or pop, at that time we'll have to specify the address. So that will be the direct address, and as per the location of the stack, the data will be retrieved. Let us see these operations. So here you can see this is the internal RAM, so which is used as a stack. Now here this is the data, say X and Y. Now the stack pointer, now this is the stack pointer. When we are pushing, before that the stack pointer will be incremented, so that will become SP plus 1, and then here we are pushing X, so the X will go to this location, which is the location in the internal RAM, which will be part of the stack. Then again we are pushing Y, so again the stack pointer is incremented by 1, and then the Y data will be loaded onto the stack. So here you can see this data Y loaded onto the stack. So the stack pointer will always be incremented by 1 before pushing. Then the pop operation. Now already we have pushed these two elements X and Y. So the stack pointer will be now here at this location. Now when we pop, first it is decremented by 1. So here the decrement will take place after popping. So whatever SP, whatever data is here, that will be, we are able to retrieve that data. So pop Y. So pop Y will take the data Y and it will be loaded into particular memory or register. Then it is decremented by 1, and the next data we are retrieving from SP minus 1. So in this way the push and pop of the stack will take place. Then let us see the instructions. So for push we have the push direct. So this is push direct byte onto the stack instruction. Now this instruction increments the stack pointer by 1, and the contents of direct, which is a internal memory location or a SFR, are copied into the internal RAM locations addressed by the stack pointer. So this is little tricky, you have to understand it. Now the contents of direct, now direct is indicates the internal memory or SFR. Now SFR we have the DPH, DPL, then accumulator, B register, and there are other special function registers. So there also we can make use of those registers for the push and pop operations, and these are copied onto the internal RAM location addressed by the stack pointer. So here, yes, p plus 1, so stack pointer will be incremented by 1, so that will be new stack pointer now, and whatever is there direct we are putting here, so that will be loaded into the onto the stack pointed by s. So if you take the example push 22h, and again we are taking another push 23h. So here these are the two push operations. Now the stack pointer points to memory location 07. So as we have after reset, it will point to 07, and the contents of memory locations are 22 and 23. Now the contents of memory location 22 and 23, they are 11 and 12 respectively. So that is what we are assuming. So after these two instructions, what will happen? First, the contents of memory location 22, that is, what is the content? It is 11. So that will be pushed onto the stack, and the stack pointer, now here before pushing, the stack pointer will be incremented by 1. So SP will become 08, and that will be pushed into the stack, and again we are pushing 23h. So again the here the 12 will be pushed onto the stack, and S will be 09. So the memory locations 08 and 09 will store 11 and 12 respectively. So this is how the push operation will take place. Now if you want to understand it, we have the diagram for that. Let us say, see the contents of 07, we have just assumed that it is 00. So it is pointing, so stack pointer is pointing to 07. That is after the reset operation. Now when we after push 22, what will happen? Now the contents of memory location 22, we have assumed it as 11. So this SP will become 8 because it is incremented, and that will contain 11 now. So after the push 22, this will take place. Then again we give the instruction push 23. So now already 11 is here. Now stack pointer again it is incremented by 1. So yes, stack pointer will become 9. So the top of the stack will be here, and the contents of memory location 23, it is 12. So it will come in this location. So in this way, the contents of stack after two push instructions, you can see this is here and this is, and the stack pointer will be 09. So this is how the push operation will take place. Now let us understand the pop instruction. So pop direct, that is pop direct byte from the stack. Now this instruction reads the contents of internal RAM location addressed by the stack pointer and decrements the stack pointer by 1. So here the data read is then transferred to the direct address, which is an internal memory or a SFR. So pop direct, now this direct refers to internal memory or special function register. Now in this example we are taking the special function register DPH and DPL. These are the two special function register. Combinedly they are called as the data pointer. So this is the data pointer higher byte, and this is the data pointer lower byte. So first See, you can see the data is read from the contents of the internal RAM location addressed by the stack pointer. So here we have shown the stack pointer with bracket. So the contents of the memory addressed by stack pointer, that is directly transferred to the address direct. Now in this case the direct address is DPH. So this data will be transferred to DPH. And in this case the direct address is DPL. So the next data will be transferred to DPL. So first, whatever is the stack pointer, as per that the operation will take place. So here if you say stack pointer is 09 and the contents of memory location 07, 08 and 09, they are 30, 22 and 33. Then what will happen? First the 09, it has got 33. So this 33 will be going to DPH. And then the stack pointer is decremented by 1, so it will become 08. So 22 will now go to DPL. So DPTR will become 3322. And again we have to decrement the stack pointer after this pop. So stack pointer will become 07. So after this two pop operation, the stack pointer will be 07 and DPTR will be 3322H. Let us see this with the help of diagram. Here you can see, now this is the stack memory. So the stack pointer is pointing to 09 and this will be the memory 08 and this will be the memory location 07. So 07 contains 30, then 08 contains 22 and 09 contains 33. So first of all, when we give the instruction pop DPH, so whatever is the contents of the stack memory pointed by stack pointer 09, so 0 here it is 33, so that will be going to DPH. And then the stack pointer is decremented by 1, so SP will become 08. Then we give the instruction pop DPL, so this 22 will be going to this DPL. And again the stack pointer is decremented by 1, so SP will become 07. And the DPTR combinedly it will become 3322 because DPH is 33, DPL is 22. So in this way the pop operation will take place. So with this we come to the end of this video. If you have any questions, you can contact me on Facebook, Twitter, Gmail or Instagram, or you can put it in the comment. Then if you like the video, press the like button, share with your friends and subscribe to our channel Engineering and Technology for You. And don't forget to press the bell icon for getting notifications about future videos. Then thanks for watching. Have a nice day.